Hello, and thank you for joining us. It's my pleasure to welcome you to today's program, Unlocking and Accelerating the Connected Vehicle Services Opportunity. I'm Roberta Gamble, Partner and Vice President with Frost & Sullivan, and I'll be your moderator today, as well as giving you some insights on the topic. Today, we are joined by members of the Automotive Edge Computing Consortium, AECC, Roger Berg from Denso Corporation, Christer Boberg from Ericsson, and Sharon Barkai from Nexar. Can you tell us a little bit about yourself?
Thanks. I'm Roger Berg with Denso for 22 years. I focus my research and development activity mainly on communications and connectivity between the vehicle and the infrastructure.
Hi, everyone. Great to be here. I'm Christer Boberg, working for our group strategy with our 5G introduction and how we connect the world with 5G.
Hi, I'm Sharon Barkai. I'm the Chief Network Architect for Nexar, with background with mobile network functions and distributed databases. Right now, dealing with automotive networks.
Okay. Now, as we look at the opportunities that are being driven by the connected car, we see many challenges, but also opportunities for OEMs and their value chain partners. The connected car helps to enable sustainability, it helps to drive efficiency, it helps to make EVs possible. We see an opportunity for smart telematics that can be used in everything from the maintenance of the vehicle to creating new insurance business models. Of course, we talk about autonomy and infotainment, safety and communication, and just driving new business models and revenue streams. So for today's conversation, our question is, what do you see as the current challenges in the connected vehicle services space, and how do we overcome them? Roger, do you want to kick us off on this conversation?
Sure. Thanks, Roberta. So one of the challenges we see at least in the automotive space for edge computing, is that the automobile becomes its own sensor in a way. There's a proliferation of additional ways to gather driving and vehicle information, and that in and of itself becomes a little network inside the vehicle, and then that sensor awareness information can be spread throughout the transportation system in ways that enhance the awareness of the vehicles and the system as to how the traffic is behaving, how the vehicles are behaving, how the drivers are behaving. So that awareness, that sensor perception can be shared throughout the network, especially in the time and place that's important as the traffic evolves. So I wouldn't care in Houston if I knew what was happening in Seattle, but in specific neighborhoods in Houston, it's very valuable, that kind of information, that perception information of the system and my neighboring vehicles is very important for the safety and efficiency of the transportation.
Great. Yeah, no, that makes a lot of sense. So keeping it, would it be fair to say regionally focused, but with international learnings, or you're learning from the whole system, but you're making it applicable to the particular region you're in, right? Christer, what would you add to that?
Thanks, Roberta. Just to build on Roger's statement there, I think the biggest challenge I see there is really to solve that problem is to how do we get this uniform behavior, so to say, on a global scale for the automotive industry, because as pointed out, the next generation vehicle will generate a lot of data, a lot of information that need to be shared with different players on the local and global scale. And for that to be effective and for the evolution to really take off, this need to have an effective standardization to do that. And I think the best way to handle that is to have a agreement between all the actors that this is the way to do it. You define the problem, you find the ways to solve the problem, and you make what we call a blueprint of how that would work. And that is really what we try to do in AECC, define problem, finding solutions, and then present a solution sort of in public, so that all actors really know how to handle the issue. And I think that is a big thing for the industry. It has to be uniform and global.
Great, thank you. So to really know, I guess you could say to really know what you're dealing with, you have to first well define the issue, but it's a collaborative effort.
Exactly. Between all actors, right? In the end-to-end value chain.
Yeah, and so everyone shares in creating that definition, because everyone's going to benefit from resolving these issues. So maybe just briefly, what are some of the additional opportunities that we can see once some of these challenges are resolved? I know there's a myriad of opportunities to having a better connected vehicle services industry, but what are some of the top ones that you would point to?
So one of the real big opportunities we see for IoT in transportation and edge computing is that this sense of space and time awareness can really enhance the efficiency and safety of a transportation system. If I as a driver thinking when I'm driving down the roadway, I can only perceive what I can see. And I don't really get any clues from any system that's on the roadside to kind of enhance my awareness of where other drivers are, where other vehicles are, what the signal timing is. I don't have awareness of that. But if I can get that that immediate spatial and temporal awareness of what's happening, I can really enhance the the safety and efficiency of the way the transportation system works. And that additional data, when it's combined with me as a driver, as my own perception unit, so to speak, combined with the kind of perception units we get from this additional communication and data sharing, is just the sky's the limit as to what we can do in terms of that safety and efficiency.
Fantastic. Yeah, no, those are some great points. So take the learnings from a collaborative standpoint, whether you're talking about information that's being used globally or from different value chain partners, define the challenge, address it, and then apply it at a local basis, and then understand that this can really positively impact safety and other features in particular. Now, as we look at the connected vehicles, there are numerous pieces that have to play together: safety, security, remote services, infotainment, navigation. And they all rely, of course, on information and communication. And not all this information necessarily has the time or the bandwidth to make it to the cloud and back. Maybe not all the information can always sit on the vehicle. So the edge is that missing piece that bridges the two. So for today's conversation, I really wanted to better understand, dive deeper into what role does edge computing play in addressing the current challenges in the connected vehicle services space? Christer, what are your thoughts on that?
Thank you, Roberta. So to start with, I would like to say that edge compute is really about distributed computing in general. It's meaning that data need to be processed and stored where it makes most sense. Generally as close as possible to the ones using the data. And we often in this community we talk about 99.1, meaning that 90% of the data is managed in the car, will never leave the car, and 10% of that data in the car is sent to the edge, and only 1% of the data is really managed in the central cloud. And when we look at the future here with data increasing in size, it will be even more important that we have really good mechanisms for managing the distributed compute, and in this case the edge compute. So we have to be clear that data data duplications, data that is not needed really need to be filtered out as early as possible. So I think that's where edge compute really makes sense, and we will see much more of edge compute coming in the future. Is something we often call the true edge, where you really see the need for edge compute, and that's why we see automotive industries also bringing a lot of value into defining the needs for the edge compute.
Great. No, that's an excellent point. I hadn't thought that you have to sort out the stuff that's the deduplicate and also sort out the stuff that's not as important. But it sounds like Edge is having a growing role as time goes on as well. Interesting. Yeah, very interesting. Roger, what are your thoughts?
What we see as we use the vehicles or the transportation system, that there's the idea of perception is really important to how safe and how effective you can operate, or a machine can operate a vehicle. But there are things that are very important in a short period of time, and other things, and they change very rapidly. And there's other things that don't change, like, for example, where a street sign is, or where a light pole is, or where a tree is, or where parked cars are. That doesn't change as rapidly as if a children's ball goes, flies in front of you in an urban setting. And so with Edge, we can utilize different data sets to be, computed and analyzed and acted upon in different layers of a communication system and compute system architecture. And that's where Edge becomes very effective in the mobility space, because we can use data, collect data, use data, calculate it, and give it back for actionable effect in the space and time where it's necessary and where it's needed. And we think that's a really a tremendous advantage of the edge computing and a distributed computing and communication architecture.
Okay, good. No, that makes a lot of sense. So what about other, can you expound a little bit on the other services that the Edge is going to need to, other technologies and services that the Edge is going to need to connect with?
Yeah, certainly. From my perspective, there are a lot of other vertical markets that will use edge computing, not just transportation. And so I think our coordination as a community, the mobility and transportation system, our coordination with these other verticals is really important to put together a coordinated system that can achieve the objectives of some of these widespread use cases where edge computing and distributed computing networks are really valuable.
Great. No, that makes that certainly, because I know we hear a lot about, vehicle to grid, vehicle to, city, all of these vehicle to other services or other industries, like you said, the vertical industries. Again, the energy industry is a big one, but also, different markets. So it makes sense that the Edge would then be a pivotal piece across all of those areas. Great. Thank you. Christer, any final thoughts?
Maybe just adding that the need for edge in automotive is what we call a model use case. If you look further out in the next generation services on like XR, will have very similar behavior, also with a high what we call an uplink behavior, data sent to the cloud rather than download, and that will change sort of behavior of networks and also the need for edge compute. So.
Great. Thank you. Thank you very much. That's a great comment. So good conversation today, talking about Edge as that missing piece, linking the car, its increasing importance in the connected vehicles services industry, but also linking other industries. Now, as we look at embracing digital transformation across the mobility industry, we see, that the industry is really working through a lot of different challenges and opportunities, and they're really affecting the entire ecosystem, from showrooms to manufacturing to the customer interaction with the vehicle itself. So, when we talk about all these different opportunities, all these different challenges, all these drivers, all these different spaces in which a connected vehicle is going to play, it's important to try to have proof of concept demonstrations to try to, test these things out before they go live, of course. And we'd like to talk about today is the collaborative effort around that. So tell us about the AECC proof of concept program. How does it work? Who can get involved? And what are the goals?
In the AECC, we have working groups that develop use cases, that develop architectures and implementations. And then we have this new program that we started that essentially does proof of concepts. And by proof of concepts, we mean demonstrations of those use cases, demonstrations of the architectures and implementations that we propose to meet the requirements of those use cases. And then the POC program is one that actually demonstrates that these solutions can be effective in a real world implementation, and that the designs that we create within the AECC are implementable and commercially realizable, and we can demonstrate this to the industry and to the community.
So it sounds like a really critical part of advancing the market. You're, working collaboratively with members of the industry to show them which programs and services with tools can actually then be implemented and how.
Yes, exactly. And we can do this with AECC members, or if an AECC member sponsors another piece of their supply chain or their community, we can incorporate non-members in these proof of concept demonstrations.
So it's really inclusive, because you can even include companies that aren't necessarily members, though of course if you're a member then you have the advantages of being able to start and drive one of these proof of concept demonstrations.
Yes, that's exactly right.
Thank you. So can you or Christopher, can you give me some examples of some of these demos that the AEC helps to launch?
Sure. Thank you, Roberta, and thanks, Roger. So yeah, we have a number of them already in place. And the first one I could mention here is what we call the opportunistic data transfer. What it really does is that it prioritizes traffic in different ways, so that you actually can reduce the load for the mobile network at certain congestion or busy hour, if you say so. When there's a very high load in the network, you can decide what data to send when. That is a very, very important proof of concept that we have developed. The second one I want to mention is what we call enabling distributed edge for HD maps or HD mapping. So the concept of HD mapping on how we handle different type of data with static data, dynamic data, semi-static data, etc., is something that we have shown, and how we utilize the edge in the best way to do that. And the third one I want to mention is what we call the enabling geolocation parking with this AECC distributed edge architecture, and really using a concept that we call localized network, which mainly means manage and process the data that is important for this particular service, for these particular vehicles at a certain place, and in this context utilize them for geolocation parking.
So those are three very interesting demonstrations, very critical demonstrations that, as you'd mentioned at the start of our session here, Roger, all are a collaborative effort with the industry, even with people outside of AECC if appropriate, but definitely that AECC is able to generate and then prove, to the market. So we're going to be looking at free parking spot detection, a real world application of AECC's distributed edge architecture. So when we're talking about this demonstration, it's a really very fascinating case study that we're going to look at, a real life demonstration that is part of AECC's proof of concept program, and that Nexar has collaborated with them on this demonstration, on this proof of concept. Tell us about Nexar's experience with AECC and the recent Nexar KDDI Oracle proof of concept proposal. What were the main objectives? What was the outcome? Sharon, I'd love to hear from you about that.
Yes, sure, Roberta. Yeah, we joined the AECC after listening to the chairman keynote, and we realized the shared vision with what we thought, and there were other visions at the time. Now I think there's more focus on this direction, and been very active in the working group in hashing out the key issues and putting out solutions, testing them, and that all came to a head with Tokyo parking POC that we did, and I would love to tell you all about that. So our job was to find free parking spots in Midtown Tokyo, and Nexar provided the AI dash cams and the backend stack. KDDI provided the mobile network and the Mac, and Oracle Japan provided the edge compute locations, and this was part of the AECC PoC program. We used street digital twins in order to find parking over the Automotive Edge infrastructure to flush out the key issues and test the solutions. So what does that mean? So first of all, the observed entities are street segments. We are looking for free parking situations and other situations potentially. But we note that the sensors for those observed entities are not attached to the streets. They are on moving vehicles, a lot of them. And that means a given vehicle is the sensor for one twin 1 minute and another twin another minute. These are key issues of context switching and privacy and anti-tracking, which have good solutions in the AECC FAD that we tested. Next, there are the digital entities. These process the vast uploads from many cars and therefore are allocated on the edge to deal with the capacity. But we noticed that there's millions of vehicles, but most of them are mostly idle at night, and most of them are mostly active during the day and everything in between. We also note that the edge has capacity because it's very fragmented. It doesn't concentrate traffic. So we have a key issue here of elastic allocation of a fragmented infrastructure and very good solutions in the FAD that we tested. Next is the connection between the observed entity and the digital entity. And we already saw the observing sensors are moving around and the digital entities are moving around because of elasticity. So we needed a connection that can deal with that. We can't really use the web based DNS, HTTP redirects things because they highly rely on the cloud centralization to hide a lot of changes, and we don't have that in a distributed edge. And so we had to use solutions from network function virtualizations, which are in line with AECC solutions for data flow virtualization and service selection. So these are the three main pillars. There's two more dimensions that I briefly mentioned. One is the data model. We used to static maps, index the world by road segments, and we're talking here about a completely different data model of everything changes except the physical locations, which are the index. And that's a different model of interaction between the cloud and the edge. It's not a CDN, it's actually the reverse. And also, last but not least, is the services. It's not used to anyone if we find parking spots and not tell anyone. But and there are millions of vehicles and thousands of dynamic conditions like free parking or freed up parking, and we can't cross millions of vehicles time. Conditions, thousands of conditions every second. We therefore leverage the same architecture and the same network that we use for connecting sensors to digital entity to steer and replicate from any digital entity that understands there's a parking to any client which is in the observed location which is of interest. And all those were tested. The KDDI was the ref. And we verified the solutions, and most importantly, we found parking spots.
And most important, like you said, you found parking spots in Tokyo. I've been a few times, and I never have been brave enough to try driving. So, no, that's great. So a lot of variables, of course, night versus daytime, as you've said, and then also the challenges of communicating that information back, because it's only as good as, it's great to have the information, but obviously it's what you do with it, which is critical. Thank you, Sharon. That was a great presentation. Roger, anything to add from the AECC perspective?
Yeah, I think this is just a wonderful example of how the AECC works with its community. We have a company, Nexar, who has a great idea about a service. Hey, find a parking spot in the middle of Tokyo, right? We have a network operator, KDDI, who provides the the connectivity service. We have a kind of a information company like Oracle, and they all combine together to show the solution. It's not that any one of these companies could do all of this stuff by themselves, or would maybe even come up with an idea like this, but together they can show that the community can work well, and each entity can participate and play a role in really coming up with a solution that's commercially viable and usable in the wild, so to speak.
And would it be fair to say that this actually benefits all the AECC members as well as the industry at large?
Oh, absolutely. And showing the commercial viability of an idea like this is tremendously important. It shows the usefulness of a community and an entity like AECC to really, kind of encourage the industry to that edge computing for mobile use cases is viable, and it's commercially realizable with collaboration and cooperation in an edge computing community.
So again, able to find parking in Tokyo, very tough task in a collaborative effort that really helps the industry as a whole. So that was fantastic. Thank you kindly both for your time today. That was great to learn about this proof of concept project. Thank you. If you would like to see additional on-demand videos from today's program, you can find them at frost.com/VSO. And if you'd like to learn more about AECC, you can find more information at aecc.org.